was gonna ask where's your neighbor? She ran away. Maybe when you guys were about to pay the rent, she ran away. You ran away? No, she didn't hate you. She's running away from responsibility. It's time to pay the rent, so she ran away. Like you pay the rent alone. Or maybe you didn't give her food, Krista. Next time, Krista, share your food. That's why she ran away. Okay, so
你 WiFi 在用谁的 account？
你被停了，你真的被停了。因为他的名字叫嘉颖。好找人。可以。这样会不会现在就被停？太狂了吧！你会被停？我只是在猜测就被停。
I know it's too late.
what's too late, Mr. Chang?
No, he said my head is too big. I said I know.
Too big? That's not a big head.
I didn't see your head.
Can you move your Uh-oh. Better? Are you happy now?
Are you happy now?
Is this what you want?
Those of you that won't let him be, let this dude be.
You just say if you're happy, you don't have hands for Chinese. 有了吗？非常有。
Guys, are you checking the time? You're not? Okay, now check it. So, walk fast.
Yeah. 一个就是 die. 2 or more is nice.
Okay, So let me quickly explain this. This is something we're going to use throughout this topic. Sample space. Please look up sample space. The term sample space is used to represent the set of all possible outcomes. So if you perform an experiment, say the experiment is tossing a coin, you cannot get anything outside this set. So when you imagine, listen, you imagine all possibilities and you put them in a set, that collection is your sample space. Okay? You will notice that the cardinality of your sample space, by cardinality I mean the number of elements in a set. The cardinality of the sample space is actually the denominator of your probability. That is that total we always talk about. It's based on the cardinality of your sample space. Cardinality means the number of distinct elements in a set. Okay? So if you roll a dice, this is the sample space. Some will say U for universal set. When I was in my days, learning days, when I first learned sample space, we use capital S. So it's going to vary. Let's just stick to U because we are used to universal set. Now, an event is another definition we need to be familiar with. An event is actually just a subset of the sample space. It's part of that universal set, but that you can group together based on certain criteria. For example, our sample space is it consists of everything you can see when you do an experiment of rolling a die. Your event might be picking a square number. So picking a square number will end up giving you 1 and 4, which is just going to be a part or a whole of that sample space. That is why we say event is a subset of the sample space. It doesn't have to be a proper subset. Your event could be find the probability that anybody you pick from this class is in Form 6HL. Definitely anyone you pick here is in Form 6HL. And it could be find the probability that anyone you pick in this class is from the Philippines. Definitely she will be the only one to qualify. It could be find the probability that anyone you pick from this class has more than 2 passports. Then you will have at least 2 people you can pick from here. And it could be find the probability that anyone you pick from this class is from North Korea. Then you have a 0. Empty set is also a subset of a universal set. Okay? So your event is that set that consists of outcome. Also within that sample space, but those outcomes are put together based on certain criteria that they all satisfy. So just know that the event is a subset of the sample space. It is the cardinality of your event that is your numerator when computing probability. Am I making sense? So let's look at this. I tried to distinguish between probability theory and set theory. What you call sample space and probability, we used to call it universal set in set theory. Okay? The outcomes are the elements in the universal set. So for example, if the sample space consists of the outcome of experiment of tossing a coin, H is an outcome. T is an outcome. Those are the elements of the set, isn't it? And this is the last one that I've just mentioned. So quickly, complementary event. How do you know the event you are referring to is complementary? 2 events are complementary. If only one of them can occur at a time. If the doctor says, we all know that when a human being gives birth, we are either going to give birth to a male or a female. If you have just one child, is it that child is a male or a female at the end? If the child is a male, the child can never be a female. I'm saying keep all the other constants, all the other factor constants, okay? All the other way around. Probability that if my event is, or the event is going to rain tomorrow, we can look at how many days it has rained in the week and be able to estimate our probability, right? But the event that it will rain tomorrow and the event that it will not rain tomorrow are complementary. Because it's not possible for it to rain tomorrow and not rain tomorrow at the same time. And that is why in your IGCSE days, you say if you are given the probability of a boy, you can use that to deduce the probability of a girl by doing 1 minus something. It's because that event of selecting a boy and the event of selecting a girl are complementary events. So exactly one of them can only occur at that particular time. Am I making sense? Especially if you are speaking a student. Okay? So just wanted to chip in that. And we're going to be using complement like set theory to denote that. So when we do a lot of writing, just get used to these notions. So let's write quickly. The last thing I want us to do is writing sample spaces before we maybe do a little bit of theoretical probability, and that will be the end for today. So far, at the end of this, we should be up to 11D. So 11A to D should be, will have been done. Writing sample spaces. The brain works. I want to write 3 as in the 3, and the number 3 is coming out in my head twice, and I mean a 3 like a plant. It's weird how the brain works. So 3 ways we can write our sample space. So I plan to give us maybe coins and dice. Let's begin with the simple case. We've talked about coins over there already. 1 coin, okay. So for 2 coins, please everyone pay attention, please. For 2 coins, the next thing I want us to do is how do you write out sample spaces? There will be questions that will follow very soon. So please, this is very important. How do we write out sample spaces? 3 approaches you can make use of. Of course, you need to pay attention to this if you are having more than 2 or 3 of those items. For example, if the question is just rolling a die, it's just 1 to 6. You don't need any special diagram for that. You just write open bracket, curly bracket 1 to 6. But if you are dealing with 2 dice, you are dealing with 2 coins, you are dealing with 3 coins, then you can adopt either a table, so you're going to have like a 2-way table. That's why 2-way table was introduced earlier. You can adopt the 2-dimensional grid, which is likely explained in your textbook. We're going to see one. Or you can use the 3 diagram, which is a very fantastic approach of computing probability, we shall see very soon. Okay? So if you have not done much of probability in the past, that's fine. While I'm running this very fast, at the same time, I'm not assuming we know everything, because these are the things that you should know normally. Except that we are not used to complementary event, we're not used to this, and we need to get used to those conceptual aspects of it. Understand? Now, for 2 coins, if I want to get a sample space for 2 coins, if I'm using the table, all I need to do is do a 2-way table, head, tail, head, tail. So by tabular approach, I have here head, 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 tail. I have tail, head, and I have tail, tail. Right? If I use the 2-way grid, this is similar to that. It's just like you plotting a graph. So head, tail, head, tail. So head, head will be here, head, tail will be here, tail, head will be something like that. This is the 2-way grid. then the coordinates of point where you are determines what you get. So it's just like the table. And if you use the tree diagram, you go in 3 branches, 2 layers, because there are 2 coins. So you have your coin. The first will give head or tail. But the fact that the first gives you head doesn't mean you're going to get head again. So the second will either be head or tail again. And the fact that the first gives you a tail doesn't guarantee the second outcome. So the second outcome also has either head or tail. At the end, you trace these branches from the beginning to the end, and you get the following outcomes, which will be head, head. You trace this, you get head, tail. You trace this, you get tail, head. And you trace this, you get tail, tail. You see, regardless of which approach, you can figure out that. If you have 3 coins, what you will do normally, we can still use this for 3 coins, but it's easier with 3 diagram. If you have 3 coins, because it's a 2-way table, there's no 3-way table. We are not doing 3D here, okay? Because it's a 2-way table, one of them will be the sample space for 2 coins, and the other way will be the sample space for 1 coin. Do you understand what I mean? Then we combine it again. Do you understand what I mean? Sure? Okay. And same thing with the grid. Either the X or Y axis will consist of this outcome, and the other one will just consist of head or tail again. And then whatever the grid is tells us what you get. And if it is for the coin and for the tree diagram, we will go another layer for each. You will notice that the cardinality of the sample space is actually the number of coins raised to power 2. Is this power 2? No, 2 raised to power number of coins. So for 1 coin, you have 2 raised to power 1. For 2 coins, you have 2 raised to power 2. For 3 coins, you're going to have 2 raised to power 3. If you are dealing with 4 coins, you just have 2 raised to power 4. Some of these little things might come in handy in some word problem when you don't have time to go through, okay, how many possible things you're going to have. Am I making sense? So this is how we write sample space. I want you to try for 3 coins on your own. I want you to do it using these 3 ways. See what you can do in the next few minutes. Okay? Before we go into the... I think for this there are some problems that will be done on page 256. So question 1 of this activity will be write the sample space. So here, I should have written the sample space as a summary. So sample space, U is an head, tail, tail, head, and tail, tail. So for that activity, find the sample space when 3 fair coins are tossed. You don't have to finish all this in class. I just want to put it down for us. Then I doubt you can anyway. In the book, page 256, to do, okay, I'm going to have to select problems. Maybe we probably wouldn't do much of theoretical. We probably need to stop in this chapter. Welcome to life. Welcome to real life. I'm going to send you all. There are 6 questions there. I'm going to just pick whichever one. That'll be exercise 11C. So I suggest you pick question randomly. For example, question 1, there are 3, you can pick one from there. Question 2, pick different stuff. So I'll be sending this to our WeChat. Question 3, you don't have to do everything, just try. Rolling 2 dice should be ignored because that has been done, right? If I say rolling 3 dice, you don't have to because, okay, I wrote that in question 1. Rolling a die and a spinner with side A2. Can you see this? So here, the die will be on one side, the spinner will be on another one, so you can use the grid and the coins. Okay? So try different things. We have about, sorry, I thought I was looking at 25, I'm so sorry. I think I already passed the time. My apologies, please. I had 25 in my head. That was for 10:25.
Oh.
Then I thought, I still have 9 minutes.
No.
I'm so sorry. So sorry about that. Please quickly go to your class, you're late already. Sorry.